Microwave Office has the capability of driving an antenna with a circuit schematic. Now, this can be very important, for example, with harmonic balance simulations and power amplifiers, because the output of the power amplifier depends on the load, and if the power amplifier is driving an antenna array, as the beam changes, the load changes and the amplifier's performance changes. This capability is called Insitu. It's covered in a lot more detail in the planar EM simulation class. Let me give you a quick example here. This particular antenna that you're seeing before you is drawn in Axiom. When we look at the 3D, it consists of two vertically stacked patch radiators, and there is a port driving each one of the two patches. We're going to drive this antenna with the following schematic, and you can see the subcircuit. That would be the S parameters from the antenna on the right. The upper path, the path to port 1, has an attenuator in it and a phase shifter, and we can control those by tuning them. So let's go ahead and take a look at the pattern that we get from this. I brought up a antenna pattern here. This is a 30-degree conic cut, meaning the theta angle from the vertical is 30 degrees, and we're plotting in phi as we go around the XY plane. You're seeing the E theta for the blue curve and the E phi components with the purple. Now remember that I can tune the attenuation and phase of the driving circuit. And so as I, for example, decrease the attenuation, you can see that we're getting both radiators influencing each other quite a bit, and the pattern is changing. I'm changing here the phase between the two driving elements. We also have this capability in 3D. If I go ahead and bring up the EM structure again, over here we have an annotation, and this annotation can give us the various antenna patterns. It's under Antenna Circuit 3D. Before, without the in situ simulation, it would have been under Antenna 3D. We, of course, have the Axiom results as our source and our circuit schematic that's driving it. Let's go ahead and see how this looks. Notice we are looking at the E theta component here. So if we go ahead and take a look at the 3D, you get the pattern. And if I go ahead and move my attenuator and my phase, you can see the pattern is changing. So the schematic is actually driving the circuit in this example.